Hello everyone, I am Vignesh S, research scholar from School of Mechanical Engineering. Here I am going to give an overview of my doctoral research titled High Velocity Impact Studies on Single and Doubly Curved Kevlar-Epoxy Composite Shell Structures under Ambient and Elevated Temperature under the guidance of Dr. Sreehari VM, School of Mechanical Engineering. This research work was funded by Department of Science and Technology. Aerospace structures are highly vulnerable to impact loads, especially during takeoff and landing of aircraft. From bird strikes, hail ice, and micrometeorites are the highly reported accidents in the aviation sector. So far, the literature was reported on the high velocity impact analysis on flat plate composite laminates. But in the real case, the structures that are prone to impact are curved shell structures. The impact damage of such curved shell structures are hugely varied from flat plate laminate. So the research is required to understand the damage behavior of such structures. Temperature is also one of the important design criteria which influence the impact damage of composite material. So the high velocity impact study is required to understand the impact damage of curved shell structures at elevated temperature. In the phase 1, the Kevlar-Epoxy composite laminates were impacted at both room temperature and elevated temperature and compared with the aluminum flat plates to understand the damage behavior of the Kevlar-Epoxy composite laminates. In the phase 2, the single curved Kevlar-Epoxy composite shell structure, that is SCKECS, and doubly curved Kevlar-Epoxy composite shell structure DCKECS were impacted and analyzed. To understand the realistic impact damage behavior, we fabricated and analyzed the gas turbine composite fan blades in the phase 3. The fabrication were done using VARTM method, vacuum assisted resin transfer method, and impacted with using single stage gasket facility with the help of spherical steel projectile, and the impact velocity was between 37.97 meter per second to 88.27 meter per second and impacted at both ambient and elevated temperature of 373 Kelvin, 393 Kelvin and 473 Kelvin. And also we investigated the effect of thickness, effect of velocity, effect of temperature, and the effect of orientation and hybridization of carbon and Kevlar fiber. And after impacting, we also investigated the macroscopic damage in the composite laminates, as well as through thickness damage evaluation was done using ultrasonic testing, and also we measured the leading edge tip deflection of the gas turbine composite fan blades. The key finding of the research were the Kevlar-Epoxy composite flat plate dissipates the energy in the localized contact zone, whereas the aluminum flat plate dissipates the energy globally and deformed mode. In the curved shell structure impact study, higher the central curvature height from 2.5 mm to 10 mm, resulting in reduced the localized permanent deformation and increases the interlaminar damage area in the both single curved and doubly curved Kevlar-Epoxy composite shell structure at room temperature impact. The interlaminar damage area of the doubly curved Kevlar-Epoxy composite shell structure at 48 joule at elevated temperature exhibits a higher damage area when compared to others. At the elevated temperature, the epoxy reaches its glass transition temperature, the projectile glass transition temperature, which makes the projectile rebounds after impacting all the structures, whereas it perforates the structures at ambient temperature impact. In the phase 3, the gas turbine fan blade impact were done and reveals that at lower impact energy, the energy dissipates globally, resulting in less interlaminar damage area and higher leading edge tip deflection. While at higher impact energy, the energy dissipates more locally at the contact zone than the globally dissipating energy, resulting in lower leading edge tip deflection. I sincerely thank SASTRA University for providing excellent research support and state-of-art high-end infrastructure facilities that facilitated this work. Thank you.